Did you know that the Kubernetes secret might not actually be secret? If you have ever created secret in Kubernetes using kubectl create secret, you might be surprised to know it is just base 64 encoded, not encrypted. In this video, I'll show you how to manage your Kubernetes secrets the right way using the external secret operator with AWS Secret Manager. Let's make your Kubernetes setup more secure, automated, and production ready. Alright, let's start from the basics. In Kubernetes, secrets are used to store the sensitive information like password, API keys, and tokens. You can mount them as a file or expose them as an environment variable. For example, when you create a secret using kubectl create secret command, Kubernetes simply stores that data encoded in base 64. Let's create a secret and see what is the underlying problem that we are trying to solve in this video. Let's create a secret and see what is the underlying problem that we are trying to solve. Let me switch to the terminal and I'll create a secret using kubectl create secret command. I'll be using key as username and its value as Jack. Let's verify whether a secret is created or not. Yeah, so we have secret created. But here is the catch. Kubernetes secrets are not encrypted by default. That means anyone who has access to your cluster or etcd can easily decode them. Let me show you what I mean. If you take any secret value and run the following command, kubectl get secret, your secret key, and I'm trying to access the key which is username in my case. As you can see, the value which is written from this command is actually base 64 encoded. But you can easily decode this using following command. You can copy this value and execute command echo. Since this is base 64 and I want to decode, see, we are getting the actual value in plain text. This is the problem with Kubernetes. To solve this, production system uses the external secret manager services like AWS Secret Manager, Parameter Store, or HashiCorp Vault. These tools allow you to manage secrets centrally, rotate them automatically, audit who accessed what and when. Also, you can control the access using IAM. Now question comes, how to implement this? This is where the external secret operator or ESO comes in. It's an open source Kubernetes operator that acts as a bridge between your Kubernetes cluster and your external secret manager. It fetches secrets securely from systems like AWS Secret Manager and keep your Kubernetes secret automatically in sync. So, instead of manually updating secret, ESO handle it for you in real time. So, for this demo, I'll be using the AWS Secret Manager where I'll be storing my secrets and the external secret operator to fetch secrets from AWS Secret Manager and inject them into Kubernetes secret. And a pod can easily access those secrets since they are exposed as a native Kubernetes secrets. Alright, let's switch to the code. I've kept everything inside a single YAML file for simplicity. And you'll find this repo link in the description below. Let's go through it step by step. First, we define a simple Kubernetes secret named AWS secret. This stores the AWS access key and secret key, which ESO will use to authenticate with AWS Secret Manager. You can create this secret separately and then keep the other object into repository. Next, the secret store. This tells ESO how to connect to AWS, including which region to use and which Kubernetes secret to refer for authentication. In the implementation, you can see we are using kind as a secret store, and we have mentioned region as AP South 1 where my secret is defined, and I'll be using the access key and the secret key which I've created above for authentication. Now comes the core part, the external secret. Here we are telling ESO, go to AWS Secret Manager and fetch the secret with key Nginx secret and create a Kubernetes secret named prod secret. And we are also specifying the refresh interval, meaning ESO will check for update every minute. You can set it to any number as per your requirement. Finally, in our Nginx deployment, we are consuming the Kubernetes secret using env from field, which is referencing to the external secret which is created above. Now let's see how it works. So before we apply the changes, we need to install few Helm repositories. Primarily the external secret, and we also need to install the required CRDs. For that, you need to execute command, the Helm repo add command, to download those external secrets. Since I have all the setup ready, the installation is skipped. Then you can execute Helm repo update command followed by installing the CRD. I'm getting error because the installation is already done. Let's verify whether the CRDs are installed or not. Alright, it seems like everything is installed correctly. Now let's go ahead and apply the changes. So as I explained in the architecture overview, we'll be creating secret store, external secret, the deployment, and whatever the secrets or the key values we are fetching from secret manager will be stored as a native Kubernetes secret. So let's verify all these components one by one. Let's start with deployment, whether our application is running or not. Perfect, our Nginx deployment is running. Let's verify external secret. Let's verify external secret. Our external secret is created and also it is synced. Now let's verify the secret store. Sorry guys, ignore the last one. So I was experimenting something couple of days back and we have error from there. But if you look at the latest one, this is valid and it is created 80 seconds ago. And finally, let's verify the secret. So yeah, the AWS secret, which actually contains the access key and secret key, and the other secret, which is prod secret, which contains the value from the AWS Secret Manager. You can also use the service account if you do not want to expose your access key and secret key to the cluster. Now let's jump to the AWS. So I've created this secret called Nginx secret. So this name we are referring into our external secret object. So this section which is data from and this section which is data from has a key, and the value of this key should match with your AWS secret object. Which is Nginx secret. Perfect. It seems everything good so far. So now let's go inside the pod. I'll be using a tool called K9S, which is very user friendly. Perfect. I'm inside the pod now. As I mentioned, the values which are fetched from AWS Secret Manager, natively those are created as a Kubernetes secret, and we can access them as an environment variable. So if I execute env command followed by grep, and we have a value, we have a key named as test, and its value is 1. Perfect. Which means our secrets are perfectly synced with the pod. Now let's go ahead and update its value to, let's say, 2, and save this. As I mentioned earlier, we have a one field in the external secret which is refresh interval. For now this is set to 1. For now this is set to 1 minute, which means the external secret operator will continuously check the AWS Secret Manager whether it has any update or not. You can verify the status from kubectl command external secret demo. So this is our external secret, and then followed by kubectl describe external secrets, your secret name. Perfect. As you can see, we created secret around 7 minutes back, and this is updated 57 seconds ago. Let's check what value we have inside container. For this, I need to perform a rolling update. So since this is just demo, I'll be deleting this Nginx pod, and the deployment will create a new pod again. You can use the rolling update. Perfect. Our Nginx deployment is running. Let me exit into this. And if I check the value of test env, perfect. So this is now updated to 2. So the advantage of using external secret operator with AWS Secret Managers are we can automate the secret sync. Also, no manual updates are required. We can secure our AWS secrets using IAM based access. Also, we can versioning, and we can have an audit trail. It works across multiple environments seamlessly. And that's it. You just learned how to manage Kubernetes secrets securely using external secret operator and AWS Secret Manager. If this video helped you, don't forget to like, subscribe, and drop a comment if you have implemented this in your setup. It really helps the channel grow, and I would love to hear how you are managing secrets in your cluster. With that note, thank you so much for watching till the end.